Today, one of the important concepts creation of Spark tools. So simply what is a Spark tool means? It's a Spark cluster in Synapse workspace. So especially used to process like a very high volume of big data. Okay. And also can able to process both structured and unstructured.
Before we begin with the class, I have a question for you.
Yeah. 1 minute, Chandrasekhar.
Hello, can you hear me?
1 minute, Chandrasekhar. Do you hear me now? Hello, Chandrasekhar. Sir, any problem with my voice? Sir, all of you getting my voice?
Yes, sir.
Yeah. Chandrasekhar, you can go ahead. Hello. Chandrasekhar. I think Chandrasekhar is not able to listen me. Hello.
He has pinged this question in chat, sir.
Chandra, if you are not able to hear me, please speak in chat.
He already pinged, sir. Could you check?
So where do we use MapReduce in Synapse? Simply, sir, one thing. Chandra, just listen this answer. And all of you, please attend this. So before these cloud data platforms for big data, in market you have Hadoop. Hadoop basically is having two layers. One is HDFS. Second one is MapReduce. HDFS, Hadoop Distributed File System. This is for storage only. Okay, only use it for storage, but it cannot do any process. For processing, in old Hadoop clusters, we have job tracker. Okay, this job tracker has an execution model called MapReduce, which is outdated. Now, latest one is Spark. Simply the thing is called Spark engine. This is latest execution model and execution engine. This MapReduce is 100 times faster than regular RDBMS processes. This Spark is more faster. That means you can say even 100 times faster. MapReduce. Then simply the Synapse is giving you a provision. If you are comfortable with the MapReduce, use MapReduce. If you are comfortable with a Spark, use Spark. But no need to use this MapReduce because the world data processing engineers will be working with MapReduce. Think that still some of the jobs are existed. Still they want to process with MapReduce, they can process it. Synapse is just provisioning you cluster, that's it. Understand? But latest execution weapon, that is Spark. Understood? Chandra. Hello, Chandra, confirm me in the chat. Cost-effective solution between MapReduce and Spark, normal data volume, GBs, not in PBs, even though Spark is very best. Okay, Spark is very best. Definitely the price will be cheaper, but that price, the cheapness of that price is negligible. If there is huge difference between MapReduce and Spark, then you can consider. Otherwise, no need to touch. The difference is very little. Okay. So please check with your mic. Hello, Sushanta, please go to mute. Chandra, are you clear? Please respond immediately because there is some issue with your mic. Hello, Chandra. Okay, remaining people, please confirm me here. Are you clear about Chandra's question?
Yes, sir.
Okay. Let's come back to the thing. Generally, what is so today we understand the code shape of Spark for both structured data and unstructured data. See, storage, if you want to store structured data, you have different solutions. Unstructured data also we have different solutions. A simple example, data lake is supporting all varieties of data. But I have a data like this. There is a file called comments.txt. Okay. So here some comments by different users. Azure is one of biggest data platform. And super speed is possible by Azure. Azure is cheaper in cost. Azure is effective system. Think that these are the 4 different comments, or it is an article, or it is a story, whatever it may be. All of you check this in the Google. Please observe my screen. I'm just using one word called here. What to say? There is some names are for that. Word. That keyword, the right time I'm not getting that keyword. That is a general word, not with the technology. Word. Okay. Just before this one is completed, I will recall that word. For now, look at this. This is purely data shape is unstructured over here. Among them, Azure is one word. How many times this is repeated, sir? In the given article or in a given story or in a given comment, how many
4
times? Totally 4 times, correct. Azure 4 times. And the word is maybe 3 times, 4 times again.
4 times, yes.
One time. Like this, I want to convert this data into a structure. See, what is the advantage of such kind of word count is, for example, there is a customer review. Customer reviews about your product. Whenever this word count is applied, the worst repeated for 10 times, good repeated for 2 times, excellent word repeated for 1 time, bad repeated for 20 times. These are the reviews by many number of customers. All customer reviews are in a file. You have constructed some word count. The word count reply is like this. As a management or as a analyst, what is your understanding, overall understanding about sentiment of users? Only for this example. Come on, tell me.
It's not good product.
That means most of customers are not satisfied easily, you can understand, right? Because the words worst repeated for 10 times, bad repeated for 20 times. That means high occurrence happen to negative words. So now if you look at this raw data, the raw data is purely unstructured, but this one is, the output is structured. So I want to process such kind of things. So how to process this with the Spark? Your regular SQL cannot do. This is use case number 1 where you have to use Spark. That means, remember this point, using SQL or using ADF data flows, you cannot process unstructured text. Got it. So here you have to use, in case of Hadoop systems, olden days, that to olden days map reduce, now it is outdated. You have to use Spark. In Spark, you have basically some of the components like a Spark core and Spark ML, that means ML lib. This is for machine learning kind of applications. And Spark GraphX for graph data processing. And Spark streaming for streaming data processing. And if data is structured directly, straight away you can use Spark SQL. In this way, many components are there. Now with this Spark core, I'm going to process this data. That to this Spark core or any component can be written in many languages like Python. You can use Java and also Scala, R language, and also you can use straight away SQL. In this way, many options that you have. So here I am going to use this Python with Spark. In Spark, data objects are called RDD. RDD. That means resilient distributed data sets. Resilient distributed data sets. So what is the style? What is the architecture of Spark? Not now. The style of RDD coding you just observe. I'm keeping this file data in a file that is comment.txt. Think that this is in my data lake account. Let's say Synapse Lake 1001 or 2001. So here I have file system or a container. The primary container is my data. Under my data, my file name is comment. Okay. So first of all, you have to read this data. Generally, RDDs are created when you read data from Spark. That means a Spark context. So Spark context is used to read data and write data into your storages. This is one situation when RDD will be created. This is number one situation. And second situation, when you perform some transformation on existed RDD, other RDD will be created. Got it. When you read data from a Spark, RDD will be created. When you perform some transformation on existing RDD, another RDD will be created. There is third situation. When you parallelize local object, RDD will be created. These are the three situations. For the third situation, I will give you one example. I have a local object. Suppose local object is A. This is the shape of Python list object. 10, 20, 30, 40, and 50, 60. Okay, enough. These 6 values I have. Now this is just a Python local object. Okay, but this is not RDD. I want to parallelize this. So here I am saying some that R1 equals to SC Spark context dot parallelize. Parallelize of A. Now this is converted as RDD. Here R1 is RDD. Okay. Observe here. What is RDD? The behavior of RDD. RDD is divided into partitions. During runtime in memory. Okay. These partitions will be distributed across multiple nodes. Runtime, all nodes will be processed parallelly. RDD is simply local object, that's it. Sorry, simply a logical object. When you submit your job, runtime, these partitions are distributed into multiple nodes, and all the nodes will be parallelly processing the RDD partition data. Of course, in this example, I have only one partition. I have only one partition. Look at the second example, R2 equal to SC dot parallelize of A. A is my local object. I am saying that parallelize comma 2. Now, runtime, this R2 is divided into 2 partitions. As partition 1, the partition 1 may contain only 10, 20, 30. Partition 2 is having 40, 50, 60, like this. So here R2 is also RDD because you parallelized your local object. R2 is RDD with 2 partitions. Suppose if I trigger a query like R2.sum, The partition 1 may be submitted to node 1 in runtime. The partition 2 will be submitted to node 2. So by the node 1, the result is 10 plus 20 plus 30, which is 60. The result by the partition 2 will be 40 plus 50, 90, 90 plus 60, 150. Again, these two independent results will be collected by other node, and finally 160 plus 60, the result is 110. Think that a big RDD is having 100 partitions. 100 partitions are distributed across 100 nodes. 100 nodes are parallelly processing this data. Okay, so that when compared with previous regular processes, this is 100 times faster. That too, here the computing style is in-memory computing, not disk-based computing. All these objects stayed in memory only, RAM only. Okay, in this way, the Spark is having additional advantages. That's why among all processing system, till now in the market, Spark is super speed processing system. Got it? So this is about the third point. When you parallelize local object, RDD will be created. I'm coming to the first point. I have a file. Let's say R1 again, I'm saying R1 sc.text file. I'm giving my file path. Suppose if you are in local system, give the path like this: directory, after a subdirectory, and then give the file name. For example, I am in Azure, my storage is on Azure, your path should be like this. Okay. So this kind of understanding you will be getting by reading the documentation of Microsoft, how to access Azure blob files by using this Spark. I'm giving some path like this. ABFSS is a protocol which is compatible with the Spark. Under that, my data is the container. Under that, analytics storage 1001 is storage account. .dfs distributed file system.core.windows.net, and then give your file name. It reads the data from that particular file. Now R1 is RDD here. So this is the first situation when you read data from text file. Not text file, when you read data from a file by using Spark, that means Spark context, RDD will be created. And third situation, when you localize local object, when you parallelize local object, RDD will be created. Okay, and one more example for the second situation. I'm going with a different example. I'm taking a local object. R1 is equal to sc.parallelize of A. Now, what is the object type of R1? What is the object type of R1? Is RDD. On this RDD, the data is same thing, 10 to up to 60. I want to perform some transformation. R2 is equal to R1 dot map something. Forget about this syntax. Simply I'm giving lambda x colon x plus 100. That means for each element I want to add 100. Now if I say R2 dot collect, R2 dot collect. So here collect is an action. When you perform action, your data flow will be executed. Now the result of this R2 will be like this: 110, 120, 130, 140, 150, and 160. For each element I have added 100 value. This is one simple transformation, but I performed this transformation on one RDD. That's why R2 will also be RDD. So here R2 is RDD. All of you understand how to create your RDDs. 3 situations. When you read data from Spark file, that means the Spark context. And second thing, when you perform some transformation on existed RDD, another RDD will be created. When you parallelize local object, RDD will be created. Okay, now come back to our task. From unstructured file, I want to generate word count. I'm taking file data once again. This is my file name is comment.txt. I want to read this data from a file. Let's say data equals to. In Spark latest version, directly you have this option. Spark.read, that is one option. Okay, I use it for now. I use it with the Spark context st.text file. And give your path. absff abfss : / the container is my data, and then storage is storage account, let's say Synapse Lake 2001 .dfs .windows .core .net. Okay, / my file name. Let's say my file name is comment.txt. That's it. Now here, data is RDD, and the data type is a list object. This list has 4 elements. The first element is Azure is one of biggest data platform. Entire line as one element in this example. Second element, second line. Third line. I have 4 lines in the file. That's why 4 elements. Okay. Now, this data is not a local object. This data is a distributed object, which is RDD. Of course, in this example, how many partitions will be there in that data, that depends on this file is a Hadoop file. That means, of course, data lake. In the data lake, the backend is Hadoop file. Hadoop file is having blocks. How many blocks that file have depends on that the number of partitions will be decided. If file is bigger, if that file has 100 blocks, means now this data, while during runtime, this data is distributed into 100 partitions. Okay. Now, come to this. I am not interested about entire line. I am interested about each word. That's why one transformation I want to generate. That is words equal to. Okay. Words equal to data.map. Whenever you want to perform some transformation on each element, dot map is the function. Lambda x. Here x refers to each element. Each element is tracked into x. For that x, I want to apply split function. X dot split. For this split, default delimiter is comma. Now, if you look at the data of these words, First you tell me words is what, sir? RDD or normal object? Is RDD. Because the data is RDD, on that you have performed some transformation so that output object will also be RDD. So its data shape is like this. In a high level, that is a list, but this line is split into the words, so that again each element is a again list. Under that sublist, Azure is one word, second word is, third word is one of biggest data. I'm just writing only for the first line, and platform. This is first line. First line is converted as list, again second line. And this is for third line. And this for fourth line. In this way, if you have 1,000 lines, for all the 1,000 lines, this work will happen. Now, what is the data type, sir? Previously, it was a list. Now it is a list of list, double dimension. But I want to convert list of list into single list. Whenever you want to convert list of list into single list, simply instead of applying map, you have to apply flat map. Now the output will be like this. Everything is a single list and remaining lines, remaining words. Our data is clear like this. This flat map is doing conversion of list of list into single list. Got it. So now previously there are 4 elements. Now there are n number of words elements. Suppose 4 line contains 60 words. Here 60 elements under one single list will be there. This is second phase of transformation. Let me keep as step number. So this is step 1 I did now. This is step 2. Now in step 3, going to transform this data into more meaningful. Step 3. Pair equal to words.map. Observe here, this is my third RDD. For the third RDD, input is from second RDD. For the second RDD, input is from first RDD. Got it. Words.map lambda x, and each element I want to transform as a tuple. Because in Spark, if you want to perform any grouping aggregation, input should be pair in the form of tuple. The pair should contain only key and value. In the place of key, here x is what? X is each element. Each element is a word. I'm keeping that element as say. But in the place of value, whenever you want count aggregation, the value should be 1. Got it. Now the data is converted as like this. The output is like this. The first word is converted as tuple. Azure as word, 1 as value. Is as key, 1 as value. 1 as key, 1 as value. Next, of 1. Like this, the data transformation will happen. Now, the data type is list of tuples. Tuple is in the shape of a key value pair. That is my third transformation. In the fourth, step 4, I'm going to apply grouping aggregation. Word count equals to pair dot reduce by key. Here key is word, reduce by key. Here there is a different expression. About these expressions I will explain later. The expression should be like this: lambda x comma y colon x plus y. This is for sum aggregation. This is the expression for sum aggregation. Okay. Now finally the result of this one word count will be a list of tuples. The list of tuples has Azure 4 times, the word is 4 times, like this. If you want to collect the results, up to now only RDDs are defined, but this RDD is not yet executed. To execute this RDD, you have to perform an action, word count dot collect. When action is performed, the data flow will be starting execution from a root RDD. What is the root RDD? Very first one. Very first one is data. After that words, after that pair, after that word count. In an in-memory computing style, the two very highly massive parallel style, the processing will be happened. So especially for big volumes of data, this kind of Spark techniques are more useful. Got it? So after that, if you want to write this output into your Azure data lake, wcat dot save as text file and give your path of your data lake. Data lake container or folder. Okay. In tomorrow's session, like I will demonstrate how to write step by step all these things. So finally, here the simple advantage I could able to process unstructured data also. Got it? Okay, let me check some chart here. Sir, if you want to Chandrasekhar, if you want to go for the fuzzy search, you have to use the NLP kind of algorithms. Okay. For the to use that NLP algorithm, you have Spark ML. Of course, in latest Spark, simply that is called Spark ML. Even in reinforcement learning, in machine learning, in deep learning, these fuzzy kind of algorithms are available. Okay, manually, if you want to write this fuzzy kind of search, means write a biggest 100 lines of code in basic core Python. Understood? Chandrasekhar, and one more question. There is no limitation of number of partitions. It simply depends upon how many blocks that in the back end, how many blocks that the file is having, right? The file has 1000 blocks, 1000 partitions, 1 lakh blocks, 1 lakh partitions by default. But how much of parallel process to be done, that depends on how many number of nodes you have, and for each node, how many number of cores you have. It depends on that. On each core, one separate Spark executor will be running. Suppose a single system is having 4 cores. Within a single system, 4 parallel process can happen. Okay. Okay. The more details you will be learning into the Spark architecture. Okay, I am going to start recording of the Databricks very soon. Mostly in this week only. I will keep sharing with you. So our session agenda: how to write Spark code in your Synapse boot. Okay. Understand, this is the style, sir, how to process your unstructured text. Now, how to process structured data in Spark. That too with the Spark core only. Spark core RDD API. What is the style you will see? Let's take our regular file, which is the emp.txt. I have the fields like ID, name, salary, and gender, and department number. Next, second record, third record. In this way, many number of records are there. In this way, many number of records. Now, data is structured. Why you call this data as structured? First, you tell me. This data is cleanly having some schema. Always first field is ID, second field is name, third field is salary, fourth gender, fifth department number. So whatever the pattern you have for the first row, same pattern for second row. Same pattern is followed by each and every row. That's why this data is called structured data. I want to perform some aggregation for each gender. What is total salary? So such kind of grouping aggregation I want to perform. The equivalent SQL. In SQL, to achieve this query, you will apply this query. Select gender comma sum of salary from table EMP group by gender. I have two genders here. Finally, you are expecting male total salary, female total salary. So how to work this, how to code this? As usual, first your process, you have to read this data. I'm saying EMP is equal to sc.text file, and I'm giving my file path, my container name, my storage account name, after the DFS, I think DFS, what is that? After DFS, Windows, DFS Windows core.net. What are the path you have already have checked that path, and finally give your file name. The file name is emp.txt or csv, whatever it may be. Okay. Now, if I have 5 rows in my file, EMP is having is a list of 5 rows. The first element, only first element I am copying. That means the entire line has one single element. This is first element, second element, third element, fourth and fifth. Every line has one element. Of course, EMP is a RDD. Data type is list. List has 5 elements because 5 lines are there in my file. Okay, to achieve this one, I don't want all the fields. I just want only gender value and salary value. First, you need to separate them. To separate them, you need to apply split. I want to divide each line into the words. Now, EMP dot map of lambda x. That is, x is each element. X dot split. For this split, delimiter is comma. Based on the comma, you are splitting the line. Now the data shape will be like this. The output is a list. Each element is again a list. The first word 101, second word A, third word for the first line is 20,000, and M and 11. Because you applied split. This is first line is divided into this list object. Again, second line, third line, the fourth and fifth. This happens for each and every line. Now is a list of list. Now I don't want to apply flatten because from each one I want to, I am interested about particular values like salary and this gender. That too, I want to group the data based on the gender. Sorry, I want to group the data based on the gender. That's why gender I will keep it as gender I will keep as key. Salary I will keep as value. Okay. So final step, I'm going to construct a pair, key value pair. The words dot map of lambda x colon. The key value pair should be tuple. Tuple has two things, a key, a value. In the place of value, I am giving salary. In the place of key, I want to give that gender value. But how to get that gender from each element? Look at this line. Gender is in last second one. That's why I'm saying x of -2. -2 means last second one. Salary value, which is third one. Third one means index number, x of 2. but salary is a string here. I want to convert this into integer, int of x of 2. Got it? That style you need to follow. Gender as key, salary as value. Now, the result of this pair will be like this. From the first line, you have male 20,000. For example, second person is female, female 30,000. Third person is male again, male 50,000. The fourth person female, female 60,000. And again, last person male 90,000. Now, if you look at this pair, that is a list of key value pairs. List of tuples, each tuple is a pair. Pair has two things, key and value. Gender as key, salary as value. So according to this understanding, you please answer me. Which field you have to make it as a key, which field you have to make it as value? Anyone please answer.
So here gender will remain as key
Oh, why?
because we are considering
Because
the
here look at
requirement.
this statement. You are
Yes,
expecting nothing less than gender. By which field you want to group the data? That should be key. On which field you want to apply aggregation? So I want to apply some aggregation on salary. That's why salary should be as value. Now we can apply reduce by key. Result is equal to input is pair dot reduce by key. Lambda x comma y colon x plus y is my expression. So what is the meaning of expression? In next class, I will explain once this practical part is completed. Okay, this is the style of RDD core API. In this way, many number of transformations like dot map, dot flat map, dot filter, dot reduce by key, dot sort, dot union, dot join. These are the regular used transformations. Generally, what we are using into our data flows. In data flows, already you are using all these things. But whenever you use these things, automatically in the back end, your data flow is converted into this kind of coding. Understand? Finally, that coding will be executed by Spark cluster. But data flows are initiating runtime clusters. That means serverless. All of you understood this? So in our next class, we will be implementing, for first step, we will be creating Spark pool. Then we create some Spark jobs. That means we define Spark flows, and then we will submit the job. We can execute them. At the same time in Spark, especially in Spark, we have Spark SQL. In Spark SQL, we have a latest concept called Spark data frame. On Spark data frame also, one more example I will show you. If time favors, tomorrow only. If not favors, day after tomorrow I will show you. Okay, sir, all of you, let's meet. Sir, did you get yesterday recording?
No, sir.
No. Okay. So yesterday date was 23rd, 24th, I think. 24th and 25th, these two things I will send you. And one more thing, sir, here, a point. All of you, please attend this word. Let me stop the recording.